Hey, everybody. There's been a whole lot of confusion with lesson 4A and 4B on the Lumina homework. They have data that is data that they did a snapshot of, and then now the website has updated their data, and so there is some confusion. So in my morning class, I went back over some items just to clarify for the test. And I wanted to go ahead and do a recording of those for my online people who are not seeing me in person. I'm going to add 2 attachments to this video. So you'll have the link and you'll have the attachments that I'm talking about. So the one, the first, the one, all the things, where I started with my morning class is that there is going to be a half sheet, and actually it's a whole sheet. And the half sheet summarizes what's going on with our independent and, independent or, and our dependent and. We're not going to have a dependent or. This sheet is not allowed for use during the test, but it, I don't want to use the word simply, but if you make it make sense using your own words, then it can it be part of your brain. Now, when you do get ready to start the test, one thing that is legal is called a data dump. You don't pre-write the information, but you can take a blank piece of paper and you're starting the test and you can dump the information down on the blank piece of paper. That's a great skill. It's called data dump. But we are not allowed to bring these in the test and have them pre-written. That would be cheating our test one, and we won't be bringing any of these cards in. We want to bring it in our brain. And so at the very top of this page, it says independent and. So in class this morning, I started by saying, okay, I brought in my bag that we have in class. And I said, we're going to flip a coin and draw a marble. So we have a coin, and then the marbles that are in this bag, you need to know that there are, and can we see most of that? There are 5 red. I hope that doesn't come out backwards when I write. I wonder if I'm supposed to flip it or something. I don't know. And 3 blue and 3 yellow. And the first thing to do is to add that up. And that's not correct. That's 4 red. There are 10 marbles in our bag. And when there being the 10 marbles in our bag, the question is, what's going to be the probability that you're going to flip a coin and land on heads and then draw a yellow? So probability that we're going to land on heads and draw a yellow from the bag. And what your brain's got to do is realize this is an independent and, because flipping a coin and drawing out of a bag, they ain't got nothing to do with each other. And so looking here, we have to realize that I'm going to take the probability of the first one and multiply it times the probability of the second one, which is drawing a yellow. And then I start filling in the blanks. Probability of landing on heads is 1 out of 2. Probability of drawing a yellow, well, I've got 3 yellows out of the 10. So that's 3 out of 10. In other words, you can't see that part. Multiply the top times the top and multiply bottom times bottom in our fractions. And we get 3/20. In other words, you have to know how to do a reduced fraction or how to take that fraction and convert it to a decimal, like rounding to the nearest hundredth, or take this fraction, do the division, multiply by 100 and get it to like even 0.1%. So those are the skills that you'll need to know for the test. But right now I'm focusing on just going back and recapping. What do you need to know for the test? You need to know independent and. The other thing I went over with my students this morning is oops, I don't want to erase all of those. We talked about that if you had a coin and a dice, not 2, but just 1, and you wanted the probability, you can still see most of that, the probability of landing on tails or rolling a die and landing on an odd number. And so having said that, these are independent events, but they're or. And that's another formula on here, but it's not bad to memorize. It takes some thought, it takes some piecing together, takes some effort. But the formula says we're going to take the probability of the first one, landing on tails. We're going to add it to the probability of getting an odd number on a die, and then we subtract their combination, tails and odd number. Don't know if you can still see all of that, and yes, you can. So we'll go back in after we realize it's independent or, after we fill in the parts of what we believe are in the formula. The first one's probability, the second one's probability, add those, but subtract their probability as an and, not the or part, but the and part. Then you go back and fill in what you know or what you can draw off on the side, but probability of tails is going to be 1 out of 2. Probability of an odd number, where there are 3 of them on a 6-sided die, 1, 3, 5. Those are odd numbers. Minus, if this is an and, we got to do exactly what we did earlier in the video, and we've got to do the probability of the first one. Yep, you can see that. Times the probability of the second one. So the probability of landing on tails is 1/2. The probability of an odd number is still 3/6. So order of operations, Aunt Sally, please excuse my dear Aunt Sally, says we got to multiply first. So I have 1/2. Y'all can still see that. My students this morning immediately threw that one to 1/2. Minus top times top, bottom times bottom. Well, if this is really 1/2, I'm going to get 3/12, and I can reduce that before or after multiplying, and I get 1/4. I told them not to leave their brains at the door when they came in, and if I have 1/2 and 1/2, I got 1 whole, and 1 whole pie, and somebody eats 1/4 of it, I'm down to 3/4 of a pie. So the probability is 3/4, so you convert it to a decimal or you convert it to a percentage. So there, I did 5 problems this morning with the students. So that's 2 of them. The third one is the probability of drawing a red and a blue, but not replacing. So I'm going to do 2 draws. And the 2 draws are looking for the probability of getting a red and a blue, but I'm not going to replace what I draw. And that throws it into our third type, our dependent, where my second draw is depending on what happens on that first draw. So let's go for the first draw. If I'm looking for the probability of drawing red, when I look in there, I've got 4 marbles that are red. That's 4 out of 10. I'm going to multiply that by, and this gets us on into lesson 4B. I'm going to multiply it by the probability of red times the probability of B getting the blue, depending on such that, given that I already got a red on the first one. So on the first draw, I had 4 out of 10, but I got a red. I did say red. Yep. I'm going to leave the red out because I'm saying I'm not replacing. So now there's a marble missing. It's not a blue marble, but it's a red marble. And so I still have 3 blue marbles in there, but I don't have 10 marbles in there anymore. I only have 9. So having said that, we can do our reducing. I had some students reduce before they get started, like 2 goes into 4, 2 goes into 10. I had some students reduce here and reduce here. Either way, we're still going to need to multiply our numerators. We're going to get a 2. We still need to multiply our denominators. It'll end up being 2/15. If you happen to start here and do the 3 times 4 to get 12 and get 9b here, you can still reduce this by taking out a 6. You can take out a 6, and then that's going to work for reducing it. Then you're going to have another piece of paper that's talking a little bit more about the cancer, which I know is a very sensitive topic, and the website. So you'll need to go into lesson 4A, pull up the website, and then you'll need to go look on the other attachment that I sent, and it has numbers 5, 7, and 8. And so I'll work through number 5. I'm not going to pull up the website for the American Cancer Society, but if you go into lesson 4A and pick up the, just hover over it, right click, it'll ask if you want to open in a new tab, or you can copy the whole link. Just don't copy the period at the end of the sentence. But question 5 in the document that I've attached says, what's the probability that a US male will die from cancer if he's been diagnosed with cancer? And so if you're looking at what I just did earlier, when I put up the probability that we're going to draw a red times the probability that we'll draw a blue, given that we got a red, well, that leads us into this next formula. And the next formula, it has something like this, but it's also, well, I'll just say it's in the lesson 4B. And when you get down to where it's saying, okay, I need the probability of an A and a B, it's in my dependent area, and I've got the probability of A times, which is this piece up here, the probability of B, given that A occurred. We can rewrite that. I'm moving very quickly, so use the pause button as needed. If I divide both sides by the probability of A, that gets us to the last thing that we need to know. The probability of B, given that A has already occurred, this piece over here is going to be, that all goes away, and it's going to be what's left over here. And that gets us to what's going on this page 5, 7, and 8. So looking at 5, it lays it out for us and says, so the probability of a male dying from cancer, given that he already has cancer, that's what this says. What's the probability of a male dying from cancer, given that he already had cancer? And we've got to go find 2 things out of the website from the American Cancer Society. One, that somebody died from cancer, and another is that what's the risk of them getting it? So you might want to pause the video, go get that website up, because what's going to come up is you're going to see, can you see that? 20.5 is the number that you'll find on the chart, and we'll divide it by 40.2. This is the dying part, and this is the getting part. And when we divide it out, it comes around the neighborhood of 51%. So again, you might want to pause the recording the video and go back and look at this, but I'm going to do number 7 and then leave number 8 for you. And number 7 says, what's the probability that a US female will die from lung cancer if she is diagnosed with lung cancer? So all of this stuff is still the same as to what we're doing, but I'll say it one more time. The probability that someone's going to die, a female is going to die from lung cancer, given that she already had lung cancer, I got to go grab the number that is had cancer, died from cancer, lung cancer, in this case, female. And then this is the diagnosis or the risk of getting cancer in the first place. Looking for space on the board. And the numbers that I found is that it would be 4.2 that we died, female died from the lung cancer, and then the risk of getting the lung cancer as a female. And when I divide those out, I'm getting around 70%. So I know this was a very quick video, but it was, it went really well in my first class. I'm about to have a second class come in here and do it in person. So I'm going to share this with all of you. But specifically, I wanted to make the video for my online people. So my email still works, and I need you to keep emailing me, talking to me, but I do wish you the very best on this test.